Hi there. Today, we will learn how to make use of some of the relationships between angles, lines, and arcs within a circle to solve given question. So here we have a circle BCDE with center A, although this circle is not drawn to scale, and the angle formed at C is 2x plus 40 degrees. The angle formed at E is 2y plus 10 degrees. The angle formed at A, which is the center of the circle, that is less than 180 degrees, is 5x minus 35. And the angle formed at B, that is angle ABC, is 40 degrees. And the question is simply to obtain the value of x and y. So here, we are going to make use of two relationships. The first relationship states that the sum of opposite angles in a cyclic quadrilateral is 180 degrees. In other words, if I have a quadrilateral that is inscribed in a circle, such as quadrilateral BCDE, in such a way that the vertices of the quadrilateral touches the circumference of the circle, and I sum two opposite angles within the quadrilateral, I will get 180 degrees. Then the second relationship we are going to make use of is that the angle which an arc of a circle subtends at the center of the circle will be double or twice the angle the same arc will make at the remaining part of the circumference. So with these two relationships, we can then proceed to solve this simple question as follows. So here we have that the sum of these opposite angles, that is angle C and angle C plus angle E will give us 180 degrees. That is making use of the first relationship. So this means that 2x plus 40 plus 2y plus 10, all of them will add up to 180 degrees. And so we have that 2x plus 2y plus 50, that is 40 plus 10, will add up to 180 degrees. And if we should then subtract 50 from both sides of the equation, we will then have that 2x plus 2y will be 180 minus 50, and 180 minus 50, this will give us 130 degrees. So, since the variable x and y have the same coefficient, we can still factor it out, and this will now imply, or we then have that 2 into x plus y will be the same thing as 130 degrees. And if you should then divide both sides of this equation using the number 2, we then have that x plus y, because this will cancel this, will be the same thing as 130 divided by 2, and that will exactly give us 65 degrees. So let's call this our equation 1. So when we make use of this relationship, we obtain that x plus y is equal to 65 degrees. Now let's make use of the second relationship. The second relationship is saying that this angle at the center, which is 5x minus 35, will be double the angle at the remaining part of the circumference. In other words, 5x minus 35 will be 2 times of this angle, 2y plus 10. If we should open up this bracket by multiplying all the terms inside it with this number 2, we have that 2 times 2y will give us 4y, and then 2 times 10 will give us 20. So this means that 5x minus 35 is 4y plus 20. And if we should then collect like terms, we then have that 5x, if we should subtract 4y from both sides of the equation, we then have minus 4y here. And if we should also add 35 from both sides of the equation, so to both sides of the equation, we have that this will give us exactly 20 plus 35. And so we have that 5x minus 4y is 20 plus 35, and that is exactly 55 degrees. So let's call this our equation 2. So by making use of the second relationship, we obtain equation 2. So here now, we now have systems of equation involving two variables. And we can go further to solve equation 1 and equation 2 using either substitution method or elimination method. But it is advisable to make use of substitution method here because neither of the variables in equation 1 or equation 2 have the same coefficient. So it is much easier to work this equation, simultaneous equation, using substitution method. And if we should do that, from equation 1, we can decide to make either the variable x or the variable y the subject of the formula. And if we should decide to make y the subject of the formula, we then have that our y will be the same thing as 65 minus x. That is, when we subtract the variable x from both sides of the equation, we will have that y is equals to 65 minus x. And if we should then call this our equation 3. So at this junction, what we do is we then replace y in equation 2 because we made it the subject in equation 1. We then replace this y in equation 2 using 65 minus x. And if you should take that step, we then have that 5x minus 4. So instead of this y, I now have 65 minus x. All this will give us 55. So we then open this bracket by multiplying all the terms inside using minus 4. And so we now have our 5x minus 4 times 65. That will give us minus, this will give us minus 260. Then minus 4 times minus f will give us plus 4x. This will exactly give us 55. So we then have that 9x, that is 5x plus 4x, will give us 9x minus 260 will be the same thing as 55. So when we then collect line terms, by adding 260 to both sides of the equation, we now have that 9x is 55 plus 260. And this means that 9x will be 55 plus 260. That will exactly give us 315. So at this junction, we then divide both sides of this equation using the coefficient of x, that is 9. And if we do this, we then have that x is equal to 315 divided by 9, and that will exactly give us 35. So that means that our x is 35. Now, we then replace x with 35 in equation 3. Already equation 3 states that y is equal to 65 minus x. And we have obtained our x to be 35. So our y will be 65 minus 35. And if we should do the subtraction, 65 minus 35, that will simply give us 30. So therefore, our x is 35 degrees and our y is 30 degrees. Bye.